Hi, I'm Adam Shepherd.
And I'm Jane McCallion.
And you're listening to the ITPro Podcast, broadcasting to you from the quarantine zone formerly known as the UK. So, Jane, you are back with us this week after your bout with the dreaded Roni.
Yes. I have, what I believe and have self-diagnosed, like most other people who have had it, was coronavirus. So thank you once again to our colleague Kumaz for stepping in and filling my shoes. I think I possibly tempted fate a bit by writing an opinion piece that was published on Friday before, about how boring being in isolation is, and I think fate heard me and was like, oh, you think you're bored now? Here, have another 7 days. But I'm much better, thank you. I've not been outside because I still have a dreadful cough.
I, meanwhile, have not left the house due to my usual reasons of laziness. So, most other people, as it turns out, have also not been leaving the house, as will come as very little surprise to most people. But they have, in fact, been falling back on video conferencing services such as Zoom. But it's getting even worse for the beleaguered video conferencing service. As we covered in last week's podcast, Zoom has been racked by a number of slight, not scandals per se, but minor blips, most notably the rash of Zoom bombing. So this week, following a stock plunge over the aforementioned Zoom bombing concerns, as well as being banned by a number of institutions, companies and governments, including Taiwan's whole government, the company has now brought on board Facebook's former CSO to help shore things up at the company from a security perspective.
Yes, so Alex Stamos, who left Facebook in 2018 following the revelation of Russian interference on the platform, and indeed has never been replaced, he has been brought into Zoom as an external consultant, which I think it's important to note that he isn't, a new hire or anything, to, I guess, kind of bolster what they say they're already doing, because Zoom, that they've said this is not a indication that the platform is or ever has been, unsecure. It's just that they want to show that they are, taking these concerns seriously and have an extra pair of eyes, I guess, to kind of go, oh, actually, have you looked at X, Y, and Z? Try and, like I say, just shore themselves up a bit.
There seems to be some amount of confusion around Zoom and its relative security. Mm-hmm. But none of the problems have stemmed from any vulnerabilities or insecurities in Zoom's actual technology. All of the issues have been around users not correctly configuring the security policies and tools that Zoom has put in place for users to safeguard themselves. Things like not enabling the waiting room feature to pre-screen meeting attendees and not correctly setting the meeting passwords, things like that.
Yeah, do you know what it reminds me of a little bit, with the whole thing resting on misconfiguration? It reminds me of Amazon S3 buckets.
I knew you were going to say that.
There's nothing inherently wrong or unsecure with them, but if you don't set it up properly, if you don't, if you have it on the public-facing internet without a password, then people can get in and read your data. And it's kind of the same as Zoom. It's like, well, if everything is open and you've got no screening for people coming in, and you accidentally put up your meeting ID number or whatever, then you run the very real danger that this is going to turn from a business video conference into a chat roulette session.
Well, quite. And I think it's worth noting that the security measures that AWS eventually did roll out to fix that issue, namely enabling passwords by default and forcing users to set up security safeguards when they opened those buckets, are very similar to what Zoom is now rolling out, i.e. making sure that those protections, things like the waiting room feature, things like meeting passwords, are enabled by default for all users and that they actively have to be turned off. So that's already been rolled out. That's one of the headline kind of fixes that Zoom has implemented as a direct result of these concerns.
I mean,
But
it's a privacy by default thing, really, isn't it? These things so often are. If people can misconfigure things, or rather, if they don't do some configuration, things are going to go wrong. That's the whole point of why you want privacy by design, because that's going to be a problem for your customers, for yourself, in terms of publicity or bad publicity. It's a classic Silicon Valley story, really, isn't it? A startup or a smaller firm that gained popularity very quickly, scaled very quickly, but in face of massive demand, and then kind of had to fight some fires afterwards. Meanwhile, NVIDIA has joined the fight against coronavirus alongside IBM, the US Department of Energy, and the White House. That might sound a little bit strange if you're only familiar with NVIDIA for their gaming-focused graphics cards, but the company actually has a huge role in supporting high-level scientific research.
So NVIDIA, while its GPUs and graphics cards are very good for gaming, the way that they process information also makes them perfectly suited to crunching through large data sets. And the company produces a wide range of graphics cards and supercomputer components for this very purpose, which it is now donating and lending to the fight to research vaccines and cures and other preventative measures for the COVID-19 virus.
Yes, and this consortium or collaboration, whichever way you want to look at it, I guess, NVIDIA is also giving access to their Saturn V supercomputer, not Rocket, to do a bit of that. Yes, I'm really that much of a nerd.
So this falls under the auspices of the COVID-19 High Performance Computing Consortium, which is a private-public partnership led by the White House Office of Science and Technology Policy, as well as the US Department of Energy and IBM, along with a number of high-profile tech companies that are helping to kind of join the fight, as it were.
Yeah, and as you've mentioned, NVIDIA has been involved in this field for a while. They've been collaborating with Folding at Home since 2007, which allows people to donate unused GPU clock cycles to help disease researchers. So not just COVID, although that's been added, but also things like Alzheimer's and Parkinson's.
It's sort of like cryptojacking malware, but used for good.
Yeah, like if you accidentally got a Bitcoin miner in your computer, but it's on purpose, and like you say, it's a COVID miner, we're a COVID basher.
Mm-hmm. NVIDIA has also put up its GPU-enabled Parabricks genome research kit, free to researchers who are researching the coronavirus, free for 90 days for any researcher who wants to use it for genome analysis. And finally, it seems that the tinfoil hat brigade are at it again, with news that 5G masts up and down the country are being vandalised or even destroyed over fears that they may be spreading coronavirus.
Yes, spreading or amplifying, I believe, is the issue. Now, I love conspiracy theories. They're kind of a hobby of mine, and I spend an inordinate amount of time, kind of listening to conspiracy theory podcasts of one strain or another. And just because I find it all very fun, it becomes slightly less fun when people are setting light to 5G masts because they believe that the technology, like I say, causes or accelerates coronavirus spread. And, this isn't the first time that 5G has been blamed for causing illnesses. Of course, there's the classic, which is, electromagnetic waves causing cancer. And Mark Alera, who runs BT's consumer division, including EE, has come out, and it's reported today in The Guardian, and said, the problem with this is that if people are getting so upset that they're lighting 5G masts on fire, as they have done in Birmingham and in Liverpool, that if that damages the mast, it's not just the 5G transmitters on there. There's other transmitters on there as well. And people who need to summon the emergency services, for example, would be unable to do so if they're reliant on that particular mast. Now, obviously in built-up areas, there will be other masts available to ping off. But it's so frustrating. It's so frustrating that just everything about it is so frustrating.
Now, I want to take this opportunity to stress that there is absolutely no evidence to suggest that 5G is linked to COVID-19 or coronavirus in any way whatsoever. There is some evidence to suggest that the radiation used by 5G is potentially more harmful in certain specific doses than 4G, but that's no indication that the consumer 5G currently being rolled out by telcos and by mobile operators in the UK is harmful in any way, and it's certainly no indication that it has anything whatsoever to do with coronavirus. Any stories to the contrary are, frankly, nonsense conspiracy theories, and, dangerous ones at that.
Yeah, and not even the fun kind, although there is one perhaps upside of this theory, which is probably my favourite so far 5G-related conspiracy theory, is that somehow through the power of electromagnetism, it makes grass highly flammable. So maybe those masts are just setting fire to themselves through their sheer electromagneticity. Anyway, on that note...
Never change, Internet.
Now it's time for a break, after which we'll be talking to Canonical's Nicholas Dimotakis about the joy of containers and how businesses can start building them into their development cycles.
Welcome back. Now, if you've paid any attention to the world of software development over the last few years, you'll likely have noticed the rise of container platforms like Docker and Kubernetes. They've been hailed as the easiest way to build cloud-scale applications in the fastest and most stable way possible, but perhaps the biggest endorsement of their growing importance is that VMware last year announced that containers were going to be a pivotal part of its strategy, if you'll pardon the pun.
But how can organisations start actually working with this new technology? Do you need to start redeveloping your applications from scratch? And which tools should you be using? Here to tell us more is Nicholas Dimotakis, Canonical's Vice President of Worldwide Field Engineering. Nicholas, welcome to the show.
Hi guys, thank you for having me on the show.
Thank you for joining us. So, we've heard a lot about containers over the last couple of years. They've been touted as, the answer to cloud application development. But what can containers actually do on a practical level for businesses?
So, first of all, you kind of have to think about what containers are before you can understand what they can do. Containers essentially are, in the simplest way, applications with their supporting libraries and an IP address, right? So that's pretty much what a container is. It's a way of taking your application and making it run multiple times in parallel so that you can, as it's called, scale it, and essentially make sure that all its dependencies come with this application. Then if you think about modern day applications, right, essentially you run multiple copies of an application. Think about, for example, a website which expects a lot of load, a lot of visitors. Imagine, for example, a website that is a site that sells tickets to events. Obviously, no events are happening right now, so so these sites are not at this particular moment requiring a lot of support for a lot of visitors. But at a time when a big concert is launched, its ticketing at 9 a.m. on a Friday morning, this website essentially requires to have multiple copies of it running at the same time because it expects a lot of visitors to come in at the same time. In a more traditional sense, you would have to have a lot of servers that would run the copy of this website and some sort of load balancer in the front that would essentially allow you to access the website, right? And select that this user is going to go to the copy number 526, this other user needs to go to copy number 627. If you do that on a virtualization perspective, so you can have virtual machines, this means that you need to spin up one virtual machine typically per copy of the site. Obviously that is extremely costly, and it requires a lot of effort to spin up those machines. Containers essentially came to solve problems like this. So you have your website in a containerized format. It comes out as an application essentially, and you're then able to run this in multiple copies. And the most important thing is for you to be able to also scale this out the moment you require a lot of immediate spinning of copies of that website, just because you're getting a lot of new users coming in. So this is one of the use cases of containers, right? So the ability to scale multiple copies. Another very important use of containers is to be able to have different versions of, for example, a website where you want to run it and direct users onto the older version, and then you want to introduce a new version of the website and have a very small percentage of your users go to that other version, which is basically what you would call canarying or A/B testing or something like that. That, of course, doesn't only apply to websites. This could be on any type of application, right? But the whole idea is that you can run your application in multiple copies with its libraries together and enable you to run it on all sorts of different environments and make sure that it's exactly the same copy. This is just pretty much some of the use cases that you would have with containers. There are multiple use cases that I could go on about, but just as an idea, these are the things that enterprises should be thinking about if they're starting to consider a container strategy.
So we've heard a lot about containers in connection with DevOps and agile development methodologies, particularly when it comes to deploying containers in the cloud. But is a DevOps culture and a DevOps organization a necessary prerequisite for starting using containers? Do you need to embrace DevOps before you start containerizing stuff within your environment?
Not necessarily. If you think about, again, the use cases that I was mentioning before, containers are there to solve problems. Whether the resulting application that you produce, which could be, I don't know, a multi-tiered application or a web-based application or any sort of application, if you have a methodology by which you produce this and you launch it that is not DevOps, this could easily become an application that is containerized, and you can then utilize all the substrates that can support containers to launch that application and run it there for day two operations. So DevOps is not necessarily a prerequisite. However, containerizing your application makes your DevOps process much easier, much faster, and very much optimized.
So, I mean, I remember when I first started hearing about containers, Docker was very much the word on everybody's lips, but it seems now like Kubernetes is overtaking Docker as the container platform of choice. Is that a fair observation on my part, and why do you think it's happening?
So I think it's important to clarify one thing here around Docker and Kubernetes. So Docker itself started as an engine of running containers on top of it. Essentially, Docker is a runtime that basically says, I am going to allow you to run your containerized applications on top. And I'm also going to provide this base image, and imagine a base image as something like a virtual machine, that the containers can utilize as the underlying operating system, so they can run as applications. So Docker has always been, in the beginning, a runtime, a way essentially to run those containers. The difference between the Docker runtime engine and Kubernetes is that Kubernetes is an orchestrator that utilizes a container runtime underneath. So it's one layer above, I would say. So essentially Kubernetes initially started by utilizing the Docker engine underneath on something called workers, so Kubernetes workers. So Kubernetes worker essentially is a machine with the Docker engine that is connected to the Kubernetes cluster, and on top of which worker you can actually run your containers. Now, one of the things that became extremely obvious by people starting to use Dockerized applications is that they needed some sort of orchestration, some sort of way where you can basically say, I want to run so many containers across so many machines, and other more important things such as orchestration capabilities, where I am kind of monitoring my workloads, and if I see that my workloads are not able to handle the utilization requirements, I am going to spin up more workloads. So I'm going to spin up more containers automatically. This is basically the concept of orchestration. So Kubernetes came in as an initial project from Google, which became open sourced, and very quickly it became obvious that it had all the right ingredients to become the solution of choice for container orchestration. Docker, in parallel, was running a different project called Docker Swarm. So Docker Swarm was essentially the orchestration piece from Docker, but it didn't gain so much traction, and it was built in a different approach to Kubernetes. And at the end of the day, because all of these projects essentially are as good as their adoption ratio, and Kubernetes was getting significantly more adopted than Docker Swarm, even Docker themselves realized that they actually have to now start supporting Kubernetes. And so they pretty much abandoned their approach to Swarm and actually started supporting Kubernetes. Now, here's the most unfortunate piece about Docker. Docker then, in terms of importance, became just the runtime engine, right? So if you have Kubernetes as an orchestrator on top, and you have Docker engine running essentially the containers on top of it, Docker becomes a very small piece of the puzzle. And of course, as history has shown us, Containerd came out, which is essentially an engine of running containers that is completely open sourced. And naturally, Kubernetes moved to that direction. So Kubernetes now, by default, is being distributed with Containerd instead of Docker engine. And unfortunately, Docker made some other mistakes, sending some sort of cease and desist letters to all sorts of companies that were distributing the community edition of Docker, which created, of course, all sorts of problems, misunderstandings, certain legal proceedings, after which Docker was pretty much abandoned and has lost its real value to the community. The concept of it is very much still there, but all the components are now very much open source.
So with all of these tools having been around for a while and having evolved significantly over the course of the last couple of years, as you've described, why is it only just now that we're starting to see container tech and containerized applications truly enter the mainstream in a big way?
Well, it's the same as any new technology, right? Any new technology wave has its adoption curve. You have the people who are the super early adopters, the avant-garde, then you have all the other people in the curve who are ready to start adopting these technologies. Initially, it always starts with startups who don't have too much to risk. They basically say, oh, well, there's this new technology. I can totally see it. I'm extremely agile. I can jump on it. I can grab it. I can make it my own, and I can build my whole business around it. And, oh, it's amazing because it has this whole community behind it. So I'm taking advantage of that. And I don't have to really pay anything in terms of licensing because it's open source. Once the technology becomes so prevalent that everybody sees the value of it, larger enterprises start getting into that adoption wave. And then you will see, depending on the type of enterprise, the level of adoption. So there are certain companies that are earlier adopters than other types of companies. There are certain verticals that are earlier adopters than other verticals. But it's the same story. If you go back 15 years and you talk about virtualization, you will find exactly the same type of adoption story, right? At that time, essentially, you would ask companies about moving their workloads from bare metal to virtual machines, and people would ask you, what is a virtual machine, right? Right now, can you find a single company that does not have some sort of virtualization in their environment? No. And then it's the same thing with public cloud, running your workloads on somebody else's hardware, essentially. It's the same thing. So Kubernetes is now enjoying the most attention in terms of infrastructure. People feel that it's there to solve a lot of problems, and it will actually solve a lot of problems. But then, as with any other new type of technology, it is not the be-all, end-all of solving your issues, right? There will be applications that will remain in their existing capacity running on virtual machines or bare metal. There will be a lot of applications that will move to containers. The reality is that companies are weighing the pros and cons of actually migrating their workloads into containers. And of course, they will see that certain workloads are absolutely not worth this type of migration. It's actually much cheaper to be allowed to run exactly where they're running for many years until they become obsolete and end of life, and they basically die in their existing environments. And then everything else can move to containers. And then, of course, then after that, you will see the next wave, which has already started with Lambda functions and function as a service. There's a lot of interest around that. But before we get to this becoming the hottest thing du jour, you first have to get containers being adopted and container technology, and of course, a lot of DevOps, as you were mentioning before, becoming part of this. One other important aspect, again, because you were mentioning before around security, which Zoom security, which is a very, very interesting subject. Containers are still in their early parts of the journey around security. And so a lot of enterprises are realizing that and are basically saying, I want to make sure that anything that are run on containers is actually well secured. And of course, a lot of companies are striving to jump and say, well, we have the most secure solution out there. The reality is, because containers are abstracted from the infrastructure, that doesn't necessarily mean that they're also protected. Just because you put a wrapper around an application, it doesn't mean that this application is actually going to be secure. So there's a lot of aspects that companies are evaluating right now, security especially being one of them, and of course the cost of migrating to this new technology, that will define how fast or how slow an enterprise can move to containers.
So what kind of security concerns might these be, and what can companies do to mitigate them then?
So first of all, the most important aspect of a container, as I said, is the application itself and the libraries that it uses to run. Right? If anybody is doing any software development, you basically know that you run your application and you call certain libraries. As I mentioned before, those libraries are getting included into the container itself. Software is software. Software will always have vulnerabilities. This is the definition of writing and running software in the modern age. And it's becoming even more important as things grow into open source and people writing code on GitHub non-stop. And so one of the biggest issues is to make sure that the libraries that you use inside the container are free of any critical vulnerabilities. And so there are multiple tools out there that can basically either scan the container at runtime and basically say you're actually using libraries that have clear vulnerabilities, or even if you're using a DevOps process, as you guys were basically talking about before, where during your CI/CD pipeline, you are trying to build your container and you're requesting certain libraries to be included in that container. There are tools that can basically tell you, wait a second, you're trying to include a library that we know has been compromised. Please do not use this library, use this next library, and because of that, I am not allowing you to build your container until you've actually used the version that we know is free of that specific security vulnerability. So that is for the container itself, making sure that it actually uses libraries that are secured. Then if we go to the base image itself, remember containers to run, they require a base image underneath, kind of like a VM if you think about it. That base image is an operating system. Operating systems also have vulnerabilities. So you need to make sure that that base image is constantly patched from a security perspective. You can't just think that because it is something that you don't see that it's immune from any sort of vulnerabilities as such. That needs also to be patched at that level. Then we have to go to the worker level. Remember, the worker is the machine that runs the container engine, right? Either the Docker engine or Containerd. The worker itself is also vulnerable. You need to make sure that that's protected also from critical vulnerabilities and make sure that it's absolutely patched at the right level. And of course, it's protected from a network perspective so that you can not access it outright. Then remember, Kubernetes as a whole is a platform, right? This is the infrastructure platform where your containers run on and your base images are stored. Kubernetes itself also needs to be protected. All the endpoints of Kubernetes that are being utilized for applications to access them and deploy the containers also need to be protected. So you would, for example, do some TLS encryption on those endpoints. And then from a network perspective, again, it depends on how secure you want to be or any sort of DMZ that you want to run your containers on. You have to consider all the network security that you need to apply. So as you can see, there are multiple layers that need to be considered in running your application in a containerized format. And you have to make sure that you don't make the mistake into thinking that just because something is containerized or just because something is already containerized and exists on Docker Hub, that it's already secure. It definitely is not an assumption that someone must make.
Well, sadly, I'm afraid that's all we're going to have time for this week. Thank you once again to Nicholas for joining us.
Thank you guys for having me on the show.
You can find links to all of the topics we've spoken about today in the show notes and even more on our website, www.itpro.co.uk.
You can also follow us on Twitter, Facebook and LinkedIn.
And sign up for our daily newsletter or our newly introduced business briefing, which rounds up some of the best news and exclusive content from ITPro, Money Week and The Week.
Don't forget to subscribe to the ITPro Podcast on Apple Podcasts, Spotify, Stitcher, or wherever else you find podcasts. And you can get in touch with the show by emailing podcast@itpro.co.uk.
We'll be back next week with more news and analysis from the world of IT. Until then, goodbye.
Bye.
The
The ITPro Podcast is brought to you by the Dennis Podcast Network.